I'm Mark Arenes, and this is Euler's Melting Pot. In this challenge, we try to complete every Project Euler problem in a different programming language. Today's challenge is problem number 29. Let a and b be integers ranging from 2 to 100 inclusive, and consider the powers a to the b produced by this iteration. Count the number of distinct terms in this sequence. There's not a whole lot of wild math to discuss here. We'll need 2 loops, each of which will iterate about 100 times, for a total of 10,000 iterations. That's easily within range to brute force. The one minor point of complexity is the constraint that we're looking for only distinct terms. So we'll start out by working in a language that has a built-in set data type. Let's write the draft today in Raku. This shouldn't take very long since the problem is pretty simple. We'll store our values in a set hash, which is Raku's mutable set data type. Iterate for a from 2 to 100 and b from 2 to 100. Inside the loop, add the power to our set, then print out the length of the set at the end. Raku, like Python, uses double star for the power function. And unlike Python, the method to get the number of elements in a list is not length or size, but elms. Aside from that, this works instantaneously. There's not a whole lot of magic here, so we'll just need to translate this into some terrifying language in a minute. But first, this programming language is Raku. Raku derives from Perl, which is absolutely known for its clever one-liners. So surely we can get this down to one line, right? In fact, it's pretty straightforward to do so. The capital X in this code is a built-in meta operator which performs a Cartesian product operation on the list to its left and the list to its right, using the operator argument specified to combine elements. In our case, the power operator is our chosen argument. Then we simply ask for the unique elements from this list and print the result. By the way, in case the word meta operator sounds too academic for you, Raku's meta operators are simply what J calls adverbs, except that Raku takes its operator argument on the right, while J takes its argument on the left. So x star star in this code snippet is the x meta operator applied to the star star ordinary operator, in the same way that we would sum a list in J by applying the slash adverb to the plus verb. With that out of the way, let's get straight to business. Today, we'll be working in Seriously. No, that's actually the name of the language. The language is actually called Seriously. Someday later, we may seriously use its successor language, which is called Actually, but for now, we're actually going to write some Seriously code. Seriously is a relatively straightforward golfing-based programming language. We have access to a global value stack, 2 random access registers, and a single global random access array. The valid data types in Seriously are numbers, strings, lists, and functions. And the interpreter is written in Python, so numbers are arbitrarily large, provided we remain within the realm of integers. Seriously code consists of single-character commands which are, generally speaking, run in order. There are nearly 200 commands available, all of which are listed on the ESOLang wiki page for the language. And, like GolfScript, many of these commands are overloaded to work differently on different argument types. Seriously uses the character set of code page 437, the code page of the original IBM personal computer. Fortunately, the interpreter will happily accept a UTF-8 encoded file and translate it for us, but that's why some of these character choices are going to look a bit random at first. Seriously features commands from all over the mathematical spectrum, from basic things like addition and subtraction, to trigonometry, to the statistical error function, to Fibonacci sequence generation, and so much more. So today, we'll only be discussing what we need for this challenge. First off, as is so often the case in these stack-based ESOLangs, a single digit pushes that digit's value onto the main stack. So the numbers 0 to 9 push themselves onto the stack. Other data types are also fairly straightforward. Strings are enclosed in quotation marks and push themselves as strings onto the stack. Lists basically borrow Python's syntax. That is, they're enclosed in square brackets with individual elements being separated by commas. A list literal constructed in this way can only contain literal constant values, and in fact, the interpreter uses Python's literal eval function to do so. This means that the program 1, 2, 3 pushes 3 values onto the stack, the numbers 1, 2, and 3. But the program 1, 2, 3 enclosed in square brackets pushes a list containing the single value 123 onto the stack. Arithmetic is done in the usual way, with plus, minus, times, and forward slash. Forward slash implements floating point division. One point of note is that the order of arguments for all commands, including arithmetic, is reversed from that of most stack-based languages. That is, in GolfScript, CJM, or really any of the stack-based languages we've worked in so far, if we push 3 and then 1 to the stack and then execute a minus instruction, we get 3 minus 1, which equals 2. But in Seriously, if we push 3, then 1, and execute a minus instruction, we actually get 1 minus 3, or negative 2. This swapped argument order is true for most commands in Seriously, so we'll need to keep it in mind. We also have access to a power function represented with the caret. Like subtraction and division, the arguments are also swapped from the order you might expect. So the caret command raises the top element of the stack to the power indicated by the second element down on the stack. We also have shortcuts for raising 10 and 2 respectively to the given power. And this is where the character set starts to look a little funny. The command names for these two convenience functions are box drawing characters of all things. Similarly, the lowercase u character is shorthand for incrementing the top of the stack, and capital D is shorthand for decrementing the top of the stack. Seriously gives us access to two registers, numbered 0 and 1. These are the commands for interacting with registers. And no, I don't really know what the pattern is supposed to be here. This down and left box drawing character pops from the stack into register 0. The up and left box drawing character pops from the stack into register 1. Then these two hybrid box drawing characters push the value in register 0 and register 1, respectively, onto the stack. You'll note that I haven't mentioned any looping constructs yet. Seriously has a couple of different ways to loop. The most general purpose is the capital W command. Well, more precisely, the capital W delimiter. A pair of capital W's in your code delimits a while loop, and it works about like you'd expect. At the start of the loop, we peek but do not pop the top of the stack. If the value is falsy, terminate the loop. If the value is truthy, run the loop once and then check the condition again. As I've already mentioned, seriously is written in Python, so it uses Python's definition of truthiness. That is, 0, the empty string, and the empty list are all falsy, and any other values are truthy. Note that since the starting and ending delimiter of a while loop are the same character, there's no way to nest this form of while loop inside of itself in seriously. The other looping constructs involve functions. Functions are just like any other value in seriously, so they can be stored on the stack or in either of our two registers. A block of code contained in backticks is treated as a function and, when evaluated, pushes itself as a function onto the stack. Like with while loops, since the delimiters are the same, we can't use this syntax to nest functions within one another. Once we have a function, we can pop it and call it with the f with hook character. Note that this isn't an ordinary f, but it's a sort of cursive f. In Unicode, it's u plus 0192, and on code page 437, it's 0 hex 9f. As with many stack-based languages, argument passing is done implicitly on the stack. So if we want to pass arguments to a function, it's our job to push them onto the stack before calling it. But more to the point, we can call a function in a loop with this other box drawing character. This pops one value off the stack, which should be a function, then it calls that function in a while loop as long as the top of the stack is truthy. Here's an example loop that prints the numbers from 9 down to 1 using this construct. We push 9 onto the stack, then we define a function. Everything inside the backticks is our function, which is pushed onto the stack and then immediately popped by the 4-way box drawing while loop command. Inside the loop, we duplicate the top of the stack, pop, and print, then decrement the value. If you run this program, it'll actually print all the numbers from 9 to 0 inclusive, not just 9 to 1. This is because, at the end of our program, the loop condition value of 0 is still on the stack. And seriously, like many languages designed for code golfing, prints out its stack automatically when the program ends. Finally, there's the map command, indicated by a capital M. This command pops two values, first a function and then a list, and it does exactly what you'd expect. For each element of the list, we push that element onto the stack, evaluate the function, and then pop a stack value to push onto a new list. That's most of the commands we'll need today. There's a couple more simple ones that we can talk about on an as-needed basis, but for the most part, that's about it. As for our approach, we're going to make heavy use of the map command. First, we'll generate the numbers from 2 to 100 inclusive in a list. Then, map some function over it. Inside that function, we'll generate the numbers from 2 to 100 once again and map another function over it, so that we end up with a large list of lists of results, which we'll then flatten and remove duplicates from in order to get our actual result. Let's get started. First, we generate the numbers 101 and 2. The former we produce by pushing 2, then raising 10 to that power and adding 1. The latter, of course, is an easy literal. Then we call the lowercase x command, which works basically like Python's range function. That is, it produces a list of all of the integers from the lower bound up to the upper bound, excluding the latter. In our case, these 5 characters have the net effect of pushing one value onto the stack, the list of numbers from 2 up to 101, excluding the upper bound. Now we'll write two functions. These are the two functions we'll be mapping over our respective lists. The first will act as our outer loop, and it'll assume that it has access to the second function in register 0. The second function will, in turn, assume that the value from the outer function is in register 1 by the time it was called. We're inside of our first function now, that is, the outer loop. By the time we're in our first function, the top of the stack is the current A value. We store that input in register 1 so the second function can access it. Then we generate the range from 2 to 101 again, just like we did the first time. Now we're assuming that the inner function is in register 0, so push the inner function onto the stack and perform a map operation. This produces a list of 99 values, which we return on the stack. Our second function isn't any more complicated. By this point, we can assume that the outer loop input, or A value, is in register 1, and the inner loop input is on top of the stack from the map command. So push register 1's value onto the stack and execute the power command. At this point, we're outside of both functions, and the two functions we just created are on the stack. Store the inner function in register 0, so the outer function will know where to find it. Now at this point in the program, the inner function is in register 0, and the stack consists of two values. On top of the stack, we have the outer loop function, which we want to run for each element of the array. and below that we have the list of all of the elements we want to run it on. This is the perfect recipe for the map command, so let's run it now. When the map command is done, there's one value left on the stack, a list of lists of all of the powers. The lowercase t command flattens a list of lists, so we'll execute that now. Now we have a list of power values, but this list contains a lot of duplicates. In Raku, we solved that by using an appropriate data structure called a set hash, but Seriously only has 4 data types, and set isn't one of them. Fortunately, there are some built-in commands that have a side effect of treating lists as sets on a temporary basis. For instance, the capital U command pops 2 lists off the stack, performs a set union, and pushes the result back onto the stack. The inputs and outputs are all lists, but during the course of execution, we treat the arguments as sets, which has the pesky side effect of removing duplicates. So in order to remove duplicates from this list, I'm going to union it with the empty list. Finally, take the length of the list and print it. Technically, we don't need an explicit print since Seriously outputs stack elements on termination, but we'll do it anyway. This runs instantaneously and solves Project Euler problem number 29 in Seriously. Next time, we'll continue the trend of Python-based golfing languages with Stock. See you guys then.